This is Sebastian. I'm an agile coach with Curiously Correct. My job is to help teams who got to a point where they're spending all their time fixing bugs and they're pulling their hair out because they can't make any changes to their code, move forward and actually develop cool new features instead.
I'm Sebastian Meine. I'm a Quality.net SQL stylist, and I help if you have code quality issues. So I work a lot together with Dennis to get you out of that bug cycle. I also can help you with performance issues in your database.
So we're here today to talk about thwarting database defects. Who has ever had a bug in their SQL code? Wow, only all of you. Okay. All right, so we can get into situations where, well, why don't we just start moving through here? Why are we here? SQL code is notoriously difficult to get right. Okay, talk about that in a second. And when we get it wrong, it stinks. So why is it hard to get right? Well, SQL code is hard to read. It's hard to write expressive code. Okay? Instead, you can end up with these giant select statements joining together 4, 5, 10, 12 different tables, where clauses with 8 different conditions in them, all kinds of things going on, those CTE things, with clauses and everything else. End up with giant long statements, and that's the norm. It's not the norm to have short, easy-to-read statements. You can end up with very complicated procedures, lots of different conditions. Oh, and by the way, we're mixing procedural code with set-based logic. Oh, it's fun. And the more you try to performance tune something, somehow it makes the code harder and harder to read. So it's hard to get right in the first place.
And then database defects are expensive. They're usually because of that, because it's hard to read, they tend to be hard to find. If you change something, you often end up changing something else that you didn't intend to change, meaning breaking something else. A bug in your database core can cause permanent corruption in the underlying data. And then if you use that data to make a business decision, you can end up making the wrong decision. You can ship out the wrong stuff. You can install the wrong stuff. You can treat a patient wrong. So it's not a good idea to have bugs in the database.
So stop it.
So stop it, yeah.
Now, by the way, you could have bugs anywhere else in your code, and they could cause the same kind of issues. But for the last 15, 20 years, people have been studying how to make all the other kinds of code easier to read and easier to write and easier to test. Not so much in the database. So there's been improvements in reducing how we write, or reducing the number of defects in the rest of our code. Let's start using some of those techniques when we write our database code. So what do we want to do? Well, we want to write code that we can maintain. We can make changes to it safely, and that's well tested, that we know that works. And when it comes down to it is when we look at delivering something to our customers, we want to give them something that does what we say it does, makes them happy, and that next week we can come back and change it and make it do the next thing that they need without wondering, did we break something? So we're going to talk about a process that helps you do that.
And that process is test-driven development. Test-driven development follows a simple idea, follows a simple cycle. And the underlying idea is to shorten the feedback cycle between creating a bug and being alerted about it. So you start out by writing a test. You write a small test looking for a a little bit of functionality that isn't there yet. Because it isn't there yet, when you execute that test, it will fail. That's actually an important step, that you go there and execute your test, because it will tell you that your test is valid. If it doesn't fail, you did something wrong, because the functionality isn't implemented yet. After you did that, you write a little bit of code. A little bit of code means you come up with the simplest way to make that test pass. And then you try it out and make sure that the test actually passes. That simplest way might be just hard coding a return value. That is okay at this point. After that, you think about what you have so far. You look at the design, you look at the readability, you look at your variable names, and if something with that isn't to your liking, you clean it up without changing the functionality. That step is called refactoring. At the end of that, you rerun your test, and they will immediately tell you if you changed functionality. After that, you start writing the next test. Again, a small step, and then you cycle through. And that was a too early change.
So who in here has seen a picture like this or heard about this process before? Okay, just about everybody. Who's tried it in their database before for writing SQL code? Okay, about 10% maybe. All right, so let's see what this actually looks like.
Let's look at some code, yeah.
So we're just going to create a little demo database here. And we're going to put into that database a unit testing framework. So if you've done any programming in other languages using unit testing frameworks, NUnit or JUnit or whatever else you might be using, utilize a framework. It gives you some tools like being able to compare values and flagging when a test fails. We're going to use a unit testing framework called TSQLT that Sebastian and I developed when we ran out of options with other unit testing frameworks that are out there.
And to just repeat that, we have a fairly small screen here, so if you're sitting in the back and have problems, there are still seats available in the front. The framework we're going to be using during this presentation is called TSQLT. It's open source. It's available at actually at tsqlt.org, and you just install that into your database. There are a few warnings when you compile it. The reason for them is that we just hadn't had the time to fix them yet, but you can ignore them. As long as you don't get an error, everything is fine. So let's look at an actual test. A test usually consists out of three areas, three steps. The first step is the assemble phase. In the assemble phase, you set up your environment. You can put data into tables. In an object-oriented world, you would create objects and things like that. There's a simple test that phase is empty. The second phase is the act phase. In the act phase, in the action phase, you execute the code that you want to test. And you might want to record return values or result sets that come out of that step. And then the third phase is a third phase where you compare the results that you got back to the expected results. Those three phases all start with an A, so we call that the AAA method. So this test executes something that's called DBO concat name. We don't know a lot about that yet, but what that test is telling us that you can call it like that. So it's probably a function. It takes a parameter and it returns a result. The result is an n varchar, or let's you can store it in an n-varchar. So this test already tells us a lot about that function, even though we haven't written any actual code yet. And then we call the method assert equals string. Assert equals string compares two string values and causes the test to fail if the string values don't match. So let's try that.
So you'll see right off the bat, Sebastian ran the test case, and now we've got some text output here.
Some black boxes.
Yeah, projector refresh issues, always fun. But we can actually read what's going on here anyway. So this is the output of running a T-SQL-T test. And you'll see, okay, well, we've got the test name here. And it cannot find column DBO or the user something something. Can we scroll to the right?
1 sec.
Everything's broken. It's
Yeah.
great. Technical difficulties.
There you go.
Ooh, PowerPoint.
So, and now I can scroll again.
Okay, so you'll see, okay, or something. Anyway, concat name doesn't exist. Okay, well, yeah, concat name doesn't exist yet because we haven't written it. We wrote a test that tells us what it's going to look like, what it's going to do, but we haven't written the function yet. This is how we get started with things. So this is the failing test that we were going to write as the first step of the process. Sebastian's job is now to go ahead and make that test pass by doing the simplest, stupidest, easiest thing he can do with the least code to make it pass.
So
Return John Smith.
The test passed in 3 parameters. So in SQL Server, we need to actually write a function that takes 3 parameters, even though the test doesn't require us to do anything with that. And then we just return a hard-coded value. And not surprising, with that in there, the test now passes. So let's move on straight to the next test.
Oh, can you enlighten us?
Just because it passed on that value doesn't mean it passes on any other value.
Very good. So the next step in the process is we need to write the next failing test. So the comment was that's not a very good test. All because it worked for that value doesn't mean it's going to work for the next value. And pretty clearly, we hard-coded the value. There's some other functionality we want to add to this function. Okay? So what we might want to start doing when we sit down here and we're saying, okay, well, I need to do some test-driven development. I want to write this function. One of the first things I do, even before I write my first test, there's a pre-step. I sit there and say, okay, what am I doing? What could possibly go wrong when I'm doing this? And I actually have a notebook sitting next to my mouse, or actually next to my keyboard. It's easier that way. When I'm writing code. And I actually just jot down all the test cases that pop in my head when they pop into my head. And that kind of preps me for what we're about to do here. And then halfway through, I'll think of some more, and I'll jot those down. And I just cross them off as I do them. And that kind of keeps me honest with it, so that I know I'm not stopping at John M. Smith. I know that there's at least another test to pass in a different name. So that's a good observation there.
However, it doesn't make that test bad. It is still a valid test that we need to have. It's just
an adequate test.
It's not the
Yes.
only test. We need more tests.
Yes.
So in T-SQL-T, all test cases live in a test case schema. We followed with the T-SQL-T framework the model that was set by the JUnit framework. So we copied the naming convention there too. In JUnit, all test cases live in a test class. So we created a procedure that is called new test class. What that does under the covers is it creates a schema and puts a marker on there, an extended property that tells the framework this is a test class. All procedures that you put into that schema that start with the word test will be treated as a test case. Procedures that do not start with the word test will get ignored. So you can put helper procedures in there too that you can call from different test cases. We like to put everything not only in one schema, but also in one file. So if this is the first line, it does not only create that schema, it also drops the schema if it exists. And because you can drop a schema only if you cleared out all the things in there first, it takes care of that too. So after that, you have an empty schema, and then you can create your test cases within the same file without having to worry about old stuff. So the first test that you see there is the first test that we wrote. Directly under that is a new test case.
So who here doesn't have a middle initial? Am I the only one? Wow. OK. We wrote this test for me because apparently I don't have a middle name, and things always get messed up. So in this case, we're going to test that an empty middle initial does not get punctuated. OK? And we pass an empty string there. We get nothing there. So let's run that test, see what we get. And the pretty obvious expectation, since we hard-coded John M. Smith, we expect it to get John Smith. We got John M. Smith back out. Let's go fix the code to make both tests pass at the same time. So now we write something that's a little more complicated. It's got a case statement. It's going to figure out whether or not there was a missing initial there.
But again, you take the smallest step. So that means you deal only with the middle initial here. You leave the first and the last name alone for now.
It's a battle between the tester and the coder.
It is, except it's the coders who are doing this, generally. So the comment was it's a battle between the tester and the coder. Now, when we're doing this in practice, it's the developers who are doing this work. They're writing the test cases, and they're writing the code. Now, I've had a lot of fun inviting testers to sit down and do this with me, because testers think differently than developers, and I've learned a great amount from doing that. This is generally a developer practice. What this does is we figured out, through this, a lot of the bugs that really annoy the testers to find, because they're the stupid kind of things that, oh man, we made a typo in the code, or we just didn't think of that one off case, and it's a defect in the system. We don't want to bother the QA team wasting their efforts on finding the stuff that should have been obvious to us in the first place. We want them to find the hard stuff that we couldn't even think of if we imagined it, and they're going to get that using their own unique skills and talents. But if they have to spend all their time figuring out every place where we put a less than sign instead of a less than or equal to sign, they'll never get there, and we're really wasting their time. So if we can do this, saves them a lot of time, they find more interesting stuff, and then we have more interesting things to fix. Oh, I think we have a question.
When you ask you create a function, and suddenly you just have these messages, so I don't know what did you.
Good point there, yeah.
OK, so the question was, we just created a function here, and suddenly we have these messages here. So Sebastian's going to explain where that's coming from.
To execute your test cases in the tsqlt framework, you have to call the tsqlt run all procedure, and that produces these messages. The reason you don't see that I'm doing that is because I put that on the Control-0 key.
It makes life so much easier when you don't have to type tsqlt.run all the time. Hotkeys are fun.
It also makes you run the test cases more often, because it's just like Control-S for save. It's just you're getting used to pressing that keyboard shortcut. So with that change here, we did actually fix all our two tests. So let's look at one more test quickly.
So we've been hard coding things up to this point, and that seems very silly. So let's put in somebody else's name and try that. So now we're going to work with Frank J. Herman. Sorry, he has a middle name. Lucky
And
guy.
again, because a lot is still hard coded, that doesn't work. So let's quickly fix that. And that's an easy fix. We just replace the hard-coded first name with a variable and the hard-coded last name with a variable. Does anybody see a problem here?
Yeah,
Okay.
pick up the middle initial.
Oh, the middle initial's still in there.
Oh, you have, I'm sorry.
Yeah, it's still in there. Good. Nobody sees it.
Okay.
Run it. Let's. Oh, I see a few people.
You're going too fast.
Sorry.
If middle initial has a period, you're going to get double periods.
Oh, I don't think that one will happen. Why don't we run the test and see what happens instead of speculating? The great part about tests is we don't speculate what the code's going to do. We run the test and it's going to tell us.
And what it is telling us that suddenly all 3 tests are failing.
Ooh, so we did do something wrong. So what is it? You'll see if we look at the results, we're missing spaces. Now, when we were preparing for this demo, we didn't plan to do that. I was at the keyboard, I broke the code, and we said, we should show this to people, because people often say, gee, you guys are just hard coding things, that's ridiculous, it's a silly small step. This is why we take these silly small steps, because as we're building all this code up, we're adding complexity a little bit at a time. Once we cross that threshold where we added some complexity that we messed up, our tests tell us we can go back and fix it, and we have all those other tests that we built to save us from making other mistakes. We could have done this, wrote that first test case, wrote all the code that we just wrote, run it, it would have failed. Then we'd still be left, okay, well, what happens if there's no middle initial? You know, we'd be missing that test case instead. So this process of taking these small steps makes sure that we get all the test cases that we actually need. Okay? Someday, 6 months, a year from now, when you've been practicing this for a while, you'll be comfortable with taking larger steps. You'll take even larger steps, and then it'll bite you. And then you'll back off a little, take smaller steps, and then you'll get more comfortable again. That's the natural learning process through this.
So the quick fix, the fix is to just put the space back in that we lost in there somewhere, and that makes all tests pass again.
Question?
Okay. I don't use SQL to do string manipulation.
Right.
I understand this is a simple example to illustrate the process, but I would kind of like to understand, one, I don't want to write SQL that just does a bunch of small steps one at a time, because under a load that will run slowly.
Okay.
I need one of those long queries eventually.
Mm-hmm.
That's what I've got to get to. So how do we do that?
So eventually, to paraphrase the question here, is eventually we write larger, more complicated code instead of just string concatenation functions. And this really isn't the kind of thing I would stick in my database anyway, normally. We're actually going to, in a second, it's a good segue into the next demo, talk about how we work with sets, which is typically what we're working with in SQL Server, is sets of data. When you start writing larger and larger procedures, whether they're views or stored procedures, my general approach is while I'm test driving it will almost force me to break it up into smaller pieces. Okay? Once I have that in smaller pieces, I performance test it. Okay? I know it functionally works. Now I need to see if performance-wise it works. If it doesn't work performance-wise, but I've got it working functionally, I'm now in a safe spot to do some performance refactoring. So I can change the code, optimize it, make it messier if I have to. But without breaking any of the tests, and now I know that my performance optimization actually worked functionally. This means I don't skip to the most performant, fastest way of doing it while I'm coding. Some people may say that's a slower way of coding. Normally, if I write the most performant thing first, I probably actually have a bug in there anyway. And it's going to be really hard to find that bug because the code's harder to read. Next is I don't know where I should spend my time optimizing the code until I've done a performance test. So why write the code? Yeah, we want to write performant code. We need to write performant code. But I need to make sure that I'm spending the time in the right area. So I don't performance optimize everything. I performance optimize what I need to. And I do that through performance testing, which is different than this. I wouldn't use T-SQL-T for performance testing. It's not good for that.
So to use test-driven development with SQL Server, load testing is a vital component of that process.
Load testing is a vital component anyway.
Of any development
right?
process.
If you don't test drive your code, do load testing. If you do test drive your code, do load testing. Because you need to do that anyway. You don't know if you've optimized your code well until you load test it. You're only taking a guess. It might be a great guess based on your experiences, but it's still only a guess.
And if you have experience with writing fast code, you can steer the TDD process to end up with a potentially fast solution anyway. You're just getting used to that. What TDD gives you is that your solution works. Might not be the fastest, but it works. If you have the fastest, but it produces wrong results, it doesn't buy you anything.
A chance to hone your resume writing skills.
Right. The fastest way to the wrong answer is still the wrong answer, right?
Another way to sort of put a spin on the value of going through all of those, what may seem like mundane tests, is they're mundane now when your head's in the code, but 6 months later, when somebody says you've got to make this change, and maybe you didn't write the original, but you got this litany of tests, if you could pass all those tests, that new feature you just added in theory, would you could say, yeah, I can move forward with this because all my existing tests pass. Like, it's not necessarily about this specific moment you're going to produce faster or better code, but it's going to live a longer time.
That's a great point. Is that something you could hear in the back? Okay. All right. I got a thumbs up, so it must be good.
If I might, how then in this process do you ensure that you're getting good test coverage?
Okay. So good test coverage is one of those things we can look at a couple different ways. In other development languages, Java and C#, for example, there are test coverage tools. They're awesome. I love them. We don't have such a thing in SQL Server. Yeah. It's not an easily solvable problem. So we don't have a way of measuring our test coverage. However, if you're doing test-driven development, you're only writing enough code to pass the test that you have and no more, that will force you to get full test coverage.
And
99.9% of the time.
That's why it is so important to take very small steps, because only with that you will get the test coverage that you need. So let's look at this test. That test in the action phase selects something from an order by month report. Again, just looking at that test case, we can select from it, so it's either a table or a view. A table we probably wouldn't test, so let's assume it is a view, and again, it doesn't exist. In the sample phase, we do something to the order table. So that view probably looks at the order table. What this test is testing, and this test has actually a name that tells us, it tells us that the order by month report should not return a row if the table is empty. And to do that, we just create a temp table, actual, and put everything in there that comes back from the order by month report. And then we create an expected table that is empty, but has the same definition as the actual table. And then we use a third equals table. The third equals table takes two tables and compares their content, the data in there. And only if the data matches, it lets the test pass.
I think there's a question.
Yes?
The hash expected and hash actual, these are set up by the framework?
No. There we have a select into that creates the actual table, and there we have another select into that creates a expected table.
Okay, but you're deleting from orders. If you're running this on a regular database, you would be throwing away all your orders. What's built in here to make sure that you're using a fake table?
So it's an excellent terminology and excellent question, and we're going to cover that in just a little while. Hold on to that thought.
But a little bit of an answer. You do not want to run unit tests in production, ever.
Yes. Don't do that.
And there is nothing that prevents you from running a delete in production. There's also nothing that prevents you from running your test cases in production. But it is not a good idea. However, the test cases, the framework wraps every test into a transaction that gets rolled back at the end of the test. So if you don't do anything stupid, like commit every open transaction within a procedure that you test, even transactions that you didn't open, that delete will get rolled back. But you can, again, write code that will break that. So there's no full safety there. So let's talk a little bit about that star. Usually it's a bad idea to write a select star. You want to be expressive. You want to be expressive in your test cases, and you want to be expressive in your code. However, this test really doesn't care about columns. Whatever is there, it will work with. That's why this test, I think, is an example where the select star is a good idea. However, to make this test pass, we need to create a view, and we don't know what column to put in there. So let's actually check that that test fails. And the first thing you see here, I'm still running all the other test cases. You always want to run all your test cases, just to see that you didn't break anything that is independent, but really was not independent.
Question.
Can you group that test? So let's say I want to just run one group of the test?
Yes.
Every test is in that test schema, the test class as we call it. And if you call t=t run instead of run all, you can pass in either the schema name or a full test case name, schema and procedure name, to run only that class or test case. So the error here is, again, expected that object doesn't exist. Invalid object name order by month report. So let's quickly create one. And again, because the test case didn't tell us anything about columns, we just put a dummy column in there. And that makes the test case pass.
So let's do something more complicated, like test something that has orders on the table. So in this next test,
again, we have the first test in the beginning of the file and put the next one just under it.
Going to wipe out what's in the orders table. We're going to put a row in there. And then we're going to make sure that the order by month report returns these rows. So down here where we have, we've created our expected table. Now we're putting a row into it and saying, OK, now there's actual data that we expect the report to return. OK? And it's got these values. They happen to be very similar values to the ones we put into the table. You also notice that we put some column names in here. A year-month column, a total amount, and an order count. You'll notice our year-month October 2011 is reflective of the date back up there. So now the view is actually starting to do some things. We're still going to hard code things for this step.
So let's look at
Just
that.
to make that easy. But Sebastian tried to compile it. It didn't compile because we reference columns that don't exist.
Didn't compile the test?
It didn't compile the test.
So we said at the beginning, you want to write a test, make sure that it fails before you write any code. And not compiling test is a valid failure. So let's put a little bit of code in so that we actually can compile this test. And for now, that's just to hard code some columns in there. Again, we leave that control 0 in because there's only the test active right now. That's looking for 0 rows to be returned, but we put some column names in. So let's try to compile the new test again. That we can compile now, and now we get a result back, a failure from the third equals table. Now let's look at that code again. A third equals table takes 2 parameters, and that is a convention that was put in place by the JUnit framework again. The 2 parameters for any assert in this framework always go in the order the expected value first, the actual value afterwards. For a comparison, it doesn't really matter in which order. If they don't match, they don't match. However, the error output that you get if they don't match makes only sense if you put them in the right order. So in this example, in the first column, there is a small arrow. That arrow points to the left. It means that row was found in the expected table. The arrow would point to the right. The row was found only in the actual table. And if there is an equal sign, that row was in both tables.
So at this point, we're really saying, OK, we've got data in this expected table, and we don't have any data yet in the actual table because we haven't returned anything yet. Test case is failing because of that. So let's adjust the view to return some data.
Based on the number of rows in the orders table. And again, the values stay hard-coded because there's no reason yet in the test cases to change that. And that makes the test cases pass. After that, you would go in and change values to make sure that you actually do not use hard-coded values in your production code. So you would put more than 1 row in the orders table, make sure that the aggregation works. For that, you might want to write a test that only looks at the aggregation column, or if you do group by, at the group by column and the aggregation column. Ignore all the other columns in those test cases. They don't matter. The advantage there is if you later on go and drop a column or add a column, it doesn't matter to those tests. If you didn't mention them, those tests will still work. So only reference in your test cases what's really important to that test. So Dennis likes question, yes.
You have only 1 row on each temp table you're trying to compare. What happens if you have more than 1 row?
Okay.
Not the same order?
OK. So OK, so the question is, and make sure I've got the question right, what happens when we start having multiple rows in our test case and the rows in the actual result are in a different order than the rows in the expected result? OK, which can happen. So when we're talking about sets, the order of the set doesn't matter. If we had an order by here, which we can't in a view, that might matter to our test and is a different story. But since this is a view, the order doesn't actually matter. So when T-SQL-T is comparing the 2 sets, the actual set and the result set, it's actually comparing the first row in the expected table against all the rows of the actual table. and then the next row in the expected against all the rows in the actual again. So it's going through and comparing them all against one another to find out the matches. Some other frameworks do that by comparing a primary key column or a generated indicator column. That can get you in trouble because a view doesn't have a primary key, for example. So we've avoided that, and it gives a full picture of what's actually happening, regardless of where the result set came from.
If you say that, then what happens if you have dupes?
If you have duplicates, what will happen? So you could have.
You can actually see that in this example.
Oh, great.
So there's one row that was in both tables, and then the same row was again in the right table, in the actual table, a second time. But we did expect a row with a different value.
So it accounts for duplicate rows, and sometimes you want duplicate rows, and sometimes you don't. So you have to put in the right stuff in your expected table to make sure that you are testing the right stuff out.
So what it does not do is try to match mismatching rows, because that is a very complex problem that can get you into trouble if you're trying to solve that. I did write a lengthy blog post about that a while back, if you're interested. It's called the Unexpected Complexity of a Table Compare Algorithm, if you search for that.
I believe there was a question in the back.
Yeah, I just had a related question. Is there, and you don't need to answer it in full detail here, but is there a pattern, like a lot of times for what I do, we're actually doing paging and sorting and filtering inside the sprock. So I presume there's a way that I can actually write a unit test that will test that the sprock is actually ordering it or filtering it as the inputs are matching.
Yes.
I mean, right now we're doing that in C# code, but I'm just wondering if I can do that in
Yes, so there are ways to do that. The short answer is yes, particularly with the filters as far as, where this column equals this or your joins or anything else. You can set up your input test data and your expected data to match what that procedure should do with that input and those parameters. So that's fairly straightforward. Testing the order of things is doable, but more complicated. And we'll kind of defer that to later. Maybe we can talk afterwards. And then were there other questions?
Does compare table also compare the schema of the table?
If the schema doesn't match, it will most likely fail.
If the names of the columns and their order don't match, it will fail. There's another procedure if you need to test the actual schemas. Called assert result set metadata equal or something. It's really long. But to compare that the metadata of the tables, the schema essentially is equal. So there's a procedure for
Columns and ends.
Yes,
Both
these columns.
If you have a big int in one and an int in the other, the assert equals table will not fail.
But the other assert method will. So there's a procedure for that. Any other questions at this point? Should we move on?
Any nice shortcut to have for populating test data? Like
Instead of insert statements?
If he's testing paging, probably he wants to fill 4 or 5 pages of data, so you have to write quite a few inserts.
So if you want to, if you're testing a paging algorithm, for example, so yes, you may have to fill in several pages of inserts depending on what your page size is. What you can do there is you can build a little setup routine that populates enough data to fill the page to write that test case. And I think I'd want to understand exactly what the code's doing to do the paging before I say that that's the right answer for that. We can talk about that afterwards if you want.
But you probably
That was a general question.
You probably have a parameter that tells you how big the page is. Make that small. If the page is only 2 rows, 2 records, and you need
I was
only.
thinking in general, because if you get in testing a lot,
Yeah.
Yes.
then probably most of your time it's going to be on setting up test data.
Yeah.
Right, data incidents. I was thinking if you have a tool or
It's-
something.
No, we don't have a test data generation tool built into it. And generally, you wouldn't want to be creating a lot of test data inside of a unit test. When you're creating a lot of test data, that's starting to look like some kind of integration test or performance test, load test perhaps. Unit tests are really designed to be, let me test this specific piece of functionality so we don't have a data generator built in here. However, let's talk about a topic that is going to help us reduce the amount of insert statements we have to write. Now, somebody forgot to put the foreign keys in the system. That was probably me. It happens all the time. So Sebastian's going to put in the foreign keys in the system. Can anybody guess what's going to happen to our tests? OK. Well, why don't we run them and find out, because that's always the best way of finding out what happens to our tests.
So we have the first 3 tests of the function. They are certainly unaffected, but all the tests we wrote for the order month report are now failing. And the reason is that you cannot insert the value null into the column. The constraint that I put on there was a not null constraint. You cannot have other constraints, like foreign key constraints. Those things get into your way testing. So the T-SQL-T framework has a procedure that's called fake table. What fake table does is it takes the table that you put in as parameter, drops it, and creates a new one that looks exactly the same but doesn't have any constraints. Now, you need to think about, to get used to that thought, what you're actually testing. In this case, you're testing the view. You're not testing the table. The table has constraints. The constraints are there to protect the data in the table. The constraints are important. However, the view, reading from the table, does not care about constraints. The functionality of the view won't change if you have constraints or if you don't have constraints. So writing your tests that are there to prove that the view is working against a set of tables that don't have constraints is perfectly fine. And that's what this fake table allows us to do. Instead of deleting from the orders table, we just put the fake table in there that creates a new orders table that is empty. And we do that with all the tests, and that makes the test cases pass again.
So a few points about this fake table concept. Yeah, we're throwing away the constraints, as Sebastian said, and the constraints don't matter in this test. Constraints are still important, and they're still code you have to write. Test your constraints. T-SQL-T provides some functionality to help you do that, such as the apply constraint procedure. We're not going to take a look at that here. Apparently, they don't give us a full day to do that.
Very inconsiderate of them.
I know. So test your constraints. They are important. Some of your code is going to behave differently whether or not constraints are doing what they're supposed to do. A stored procedure that inserts something into a table and is behaving incorrectly could violate a constraint. Make sure you test that procedure well, knowing that those constraints are there. Because when the constraint breaks, it's going to throw an exception. So make sure your stored procedure handles that exception, and write a test case to prove that that stored procedure handles that exception. The other point I want to make about getting rid of these constraints is if you don't get rid of your constraints and you need to insert a record into the orders table, and the orders table is foreign keyed to a customer's table, which is foreign keyed to their address table, which is foreign keyed to the state table, and so on, your test case is going to have to insert all that data. In fact, every test case that has to work with orders or customers or addresses, you're going to have to insert the relevant data.
Probably has to populate the entire database at that point.
Right. That's painful, and we don't want that level of pain. Make QA do it, right? QA wants that level of pain, right? QA doesn't want that level of pain either. It also does this. If I have all those insert statements inside my test case, and somebody goes and renames a column, it's going to break all those test cases, and then you're going to cry because you have to fix them all, and that's not a good situation.
Even if somebody would change the state table, this test would fail.
And you don't want that. So that's why fake table is there, because we don't want all your tests to break every time somebody makes a schema change, because it means you'll either stop writing tests because you're spending all your time fixing them, or you'll stop making schema changes, and then your schema will become a decrepit, solid mass that never changes and never adapts to future requirements. And that's also sad.
Also, if you're writing an insert procedure, you want that insert procedure to behave correctly independent of the constraints. If you went to Brent Ozar's presentation earlier today, he was talking about disabled indexes. The same way you can disable constraints. You don't want your code to start inserting wrong data just because a constraint isn't there. So the constraints are important, but when coding, don't rely on them. Test your code as if they weren't there.
I think we had a question here.
Just real quick, so you mentioned like schema changes, somebody adds columns and it theoretically invalidates some older tests. How do you guys deal with that gracefully? So like if the orders table got extended with some additional columns,
So
just ignore that on the old test as long as it doesn't break?
In every test, you want to mention only those columns, those objects that are important to that test. So if you are looking for the total order amount, if you want to make sure that that aggregation works correctly, all you need is those two columns. So if you write those tests, put only those two columns in it. And then somebody comes and says order count should really be order CNT, it won't affect those tests. There will be tests that will be affected, and you just have to fix them. But if you separate out your concerns, that will be only a few test cases.
So similarly to faking a table, and we'll just talk about this very quickly in interest of time, you might have stored procedures that talk to one another. Stored procedure A calls stored procedure B. For example, here, we want to test a stored procedure called purge all tables that iterates through all the tables in the database, or maybe all the tables in the list, and call this purge table that just purges one table in it, okay? In order to test the functionality of purge all tables, we can spy. We can put a spy in for purge table that's going to record all the parameters that got passed to it. And then we can test that it was called with the correct parameters, okay? So we can say, okay, well, we're not testing purge table, we're testing purge all tables. Let's find out what's getting passed to purge table. So spy procedure does a very similar thing to fake table, which is it replaces a stored procedure and logs what's passed to it. And then when the test case finishes, it rolls it back. Okay, so you're working on a team.
Actually,
did I skip something?
yes.
Oh, sorry. It happens. This is why we pair up.
And I might be able to get the slides working again here. There we go. So quickly, we briefly talked about that already, but the impacts of TDD are you tend to end up, or you end up with code that is testable. Just because you're writing your test first, you have code that is testable. If you go to a big existing procedure, you're most likely going to have a hard time writing tests for that, just because the person writing that at the time didn't think about testability. If you use TDD, you will end up with code that is testable. What that also means is you will end up with code that is cleaner, that is shorter, that is less coupled. So it's easier to read, it's easier to maintain, and because you have all these covering test cases, you know what functionality it provides, and that it actually does provide that functionality. Now, TDD does not find all bugs in your code. If you didn't think about a problem and didn't write a test for it, you still might have that problem in your code. If that happens, when you find it, just write the test case and then fix the problem. Writing that test case makes sure that you can't reintroduce that problem later on. It happens often in development without TDD that you fix a bug and then with the next release that bug gets reintroduced because somebody didn't know about that change and inadvertently rolled it back.
So on the last point there, real quick, before we do this. The last point here is our ability to maintain the code. We spend almost all our time working with existing code versus writing brand new, fresh code, right? People have said it's about that 80-20 rule. It's probably a bit more than that. It's probably a 95-5. We spend 95% of our time working with code that already exists and 5% of time writing new code. The more we optimize that 95% of our time and make changes safe to do there, the better off we are. So if our code's more readable, we can make changes faster. If we have automated test cases, when we change something, we know it breaks if we broke something. That's optimizing that 95% of the time. That other 5% of the time, we're probably going to double how much time that takes to write the initial code in the first place following this process. In fact, when you're first learning this process, it might even triple or quadruple the time it takes to write brand new code until you start getting into, okay, this is how everything works, and I'm moving swiftly again. But really, we want to optimize that 95% of the time. I mean, that's obvious math right there.
So we had a lot of really good questions, but because that we're a little bit behind, so we're just gonna quickly cover this topic. TDD is not enough. TDD has a big problem. You have one team member that doesn't follow the process, that doesn't care about your existing test cases, then everybody else gets very frustrated very quickly. So it is important that your test cases get executed with every change, get executed often. And there is a process that is called continuous integration that automates that. It works with source control. So if you check in your database code is code too, so it should live in source control. If you check in your database code, you can have a version CI server pull those changes and automatically execute the test cases. And if something breaks, it can send an email to the entire team telling you about that there is a problem. And then you can work together on fixing that problem as quickly as possible.
I can also tell you that it was Sebastian who checked in the change that broke the build. And then you know who to blame.
A very powerful way to get people to play the game with you. There's a lot more to say about this, and we don't really have time. However, there is one plug that we want to put in here. If you are here in this city this week, and you don't have anything to do tomorrow,
I go to work.
We offer a one-day class to get you a little more used to these concepts tomorrow. If you want to come there, you have to sign up today. Tomorrow at the door it will be too late. So use that CR code there to sign up, or use that CR code to go to my website to find the materials about this talk, the slide deck, and other things. And there's a small ad at the side that talks about the class too.
So tomorrow's class, what we'll be doing is it's actually a hands-on. You'll write tests, you'll write code that make them pass, and you'll implement a continuous integration process before you leave. So we expect, bring a laptop and actually get prepared to write some code. It won't be us just slinging PowerPoints and showing Management Studio. It'll actually be doing some work.
Yourself. And if you can't come, go to the tsqlt.org website and download the framework and play around with it yourself. And if you get stuck, send us an email. Thank you for coming.
And we'll take any questions anybody's got. Thank you.